So for 12.2, we're doing vectors, and on Friday we had vectors. A vector is used to indicate a quantity that has both magnitude and direction. We show a vector with a directed line segment, and we have the beginning point is the tail, the arrow is the tip, and also you'll hear it called the initial point for the tail, the terminal point for the tip. And we did adding vectors geometrically, triangle rule, parallelogram rule. Multiplication by a scalar affects the length of the vector. If it's a negative number, then it's going to point the vector in the opposite direction from what it was pointing. Subtraction of vectors geometrically, I wrote v minus u as vector v plus negative of vector u. So I changed the direction of u and then set it up geometrically. So one way to do it, you have vector v, you put the tail of negative u on the tip of vector v, and then the answer is the vector that goes from the tail of v to the tip of negative u. The same for the addition, but you wouldn't have the negative vector. So I talked about a position vector. So we can have a vector, two vectors are equal, they're the same vector if they have the same magnitude, which is the length, and the same direction. But if I take the vector and put it where the initial point is at the origin, then we call that the position vector, the position representation of that vector. So we did that, and then I did a problem where I plotted some points, and I drew the vector between the 2 points. And then I came back and I said, okay, now I'm going to find the position vector for that vector. And I did say then, we'll show vectors algebraically with these angle brackets. So it's kind of where we stopped on Friday, and we'll pick up from there.